George, thumbs up. All right. Hi, everyone. Today is August 23rd. My name is Paris. I work at Google. I'm a community manager here. And today we are going to do our usual community program. First things first, we always start with a demo, then we go into release updates, followed by Aaron with Graph of the Week to show us some cool data bits. And then we have a CAP that Tim Allclair is going to share with us. And for those that don't know, a CAP is a Kubernetes enhancement proposal. We'll go into some SIG updates. Today we have Openstack, storage, and apps. And then we'll go into some quick announcements and shout outs. First things first, we do have a code of conduct that we abide by. Please be excellent to each other. If anyone needs anything at all during this meeting, please feel free to ping me privately in the Zoom chat or DM me on Slack if that's your preferred route, and then we can get that sorted for you. But first things first, let's kick it off and go right into our demo. Today we have Keycloak. Keycloak, you want to take it away?
Yeah, hi. My name is Stian Torgersen. I'm the project lead on the Keycloak team. Today I'm going to be showing Keycloak running on Minikube in this case, and a couple of applications and a service that's been secured with Keycloak. So for those that don't know, Keycloak is an open source identity and access management solution that is built for web applications and REST services primarily. So the first thing I'm going to do is I'm going to set a couple of environment variables so that I can access, so that I get the host names so I can access everything from my browser. I'm going to be using ingress to be able to get everything exposed so that I can get it through my browser. So I'm creating the Keycloak deployment first of all, and I'm creating an ingress for Keycloak. And then I'm going to be doing the same for my backend service, which is a simple Node.js service. And finally, my front end, which is a simple HTML5 front end. So next thing, let's make sure that everything deployed nicely onto Kubernetes. And of course it didn't. Okay. This is not good. There we go. Okay, it was just a little bit of a delay there. Right, so I'm going to log into the Keycloak admin console so that I can configure a realm, which is where I'm going to keep all the users and clients and everything for the demo. I could have scripted this up together with the image if I wanted to, but I wanted to show creating this during the demo so that you can see what happens configuration-wise in Keycloak. So I have a pre-prepared JSON file that contains all the bits and pieces that I want inside my realm. So it's created this realm called demo, and inside there it's created a client. And this is required so that the HTML front-end application is allowed to obtain a login via Keycloak, which is all happening through OpenID Connect. I've also created one single user so I can log into the application. And I've also created a couple of roles that the application used to secure different endpoints. So I have the admin role and I have the user role. Now at the moment, my user will only have that user role. So I can take a quick look at the backend service. It's a very simple service. It just basically says hello world almost. And then I have a couple of endpoints on it. So one is secured, and this one I'm not able to access at the moment because I don't have a bearer token that I need to be able to have to invoke this service now. I can now take a look at my front-end application. So it's a very simple front-end application. And I have a login button. And what that does is that it uses the Keycloak JavaScript adapter to initiate the login with Keycloak. And now I'm being redirected onto Keycloak. So it's Keycloak that's actually displaying this login screen and not the application itself, which means that all the credentials that I'm providing here will be accessible only by Keycloak and not by the applications. And also the application doesn't have to worry about providing these screens or dealing with authenticating the user. When I'm now returned to the HTML5 front-end application, the application now has two tokens. It has an ID token that will explain some details about who I am, for instance, my username, and also my first name and last name and other things as well, if it wants to display those. But also an access token, and the access token is what it can use to securely invoke these REST endpoints. So I now can invoke this public endpoint, of course, which wasn't secured, but I can also invoke the secured endpoint, which requires this token to be sent along with the request. But at the moment, I cannot invoke the admin endpoint. So I can show how I can easily add that admin role to the user to now be able to invoke the admin endpoint as well. The next thing I wanted to show is basically how easy it is to enable login with external identity providers, so your corporate identity providers, so SAML or OpenID Connect, and also any social networks. I'm going to use GitHub in this case. I've already created some configuration in GitHub that gives me a client ID and a client secret that allows Keycloak to log in via GitHub. So all I need to do in the Keycloak side is to provide a client ID and a secret for the particular identity provider, which is the GitHub one. And now I can log out from my application. And when I log in back again, I can now see that I have the option to log in via the GitHub without having to modify the application or anything. So now I've logged into the application via GitHub, again, without reconfiguring the application or making any changes to the application. So quickly looking a little bit at the code behind today's demo. So we have our backend service first, which is a Node.js service. What that does is that it uses the Keycloak Node.js adapter, and then it basically, all it needs to do is to initialize the adapter, and now it can very easily wrap the endpoints with the Keycloak protect method to say what realm, so what roles are required to be able to invoke these endpoints. And that's all it needs to do to be able to handle access tokens and to handle these role-based permissions. And similarly for the front-end application, that basically just loads the JavaScript library, and it can now initialize the JavaScript library. It needs to tell it what realm does it want to be secured with, and also that client ID, so that Keycloak knows which client we're talking about. And now when that application is loading, I can initialize the JavaScript adapter. I have a few different options when I'm initializing it. So one is that it can check the SSO. So that means if I'm already logged into Keycloak, I will already automatically be logged into the HTML application as well. And then it can then act accordingly whether or not the user was authenticated or not. And when I'm sending requests to that Node.js service, all I need to do to be able to make sure that that secured call goes through is to include the bearer token in the authorization header. And that is it for the demo. Well, actually, if I have a couple of minutes, I can show quickly a couple of things to see what kind of features we have available in Keycloak. So not only can you have as many different providers, identity providers as you want, configured for the same realm. You can also pull in users from external user stores. So these could be LDAP stores, or we can pull in from Kerberos as well. Obviously, LDAP covers Active Directory. You can also write your own custom providers to be able to pull in users from a relational database. We are allowed to completely change the flows for authentication flows, so you can have custom steps in there if you want to. You can obviously configure password policies. We have support for two-factor authentication. And we have lots of options around how the tokens are built through client scopes and protocol mappers that allow you to define exactly what you want to have in the tokens. And at the same time, for identity providers and user federation, we have mappers there as well. So you can pull in any attributes for your users into Keycloak and then, in effect, into your tokens. We have group support. We have obviously support to manage the user sessions, and you can remotely log out user sessions, and a number of other features. So that's it for my demo. Thank you.
Very cool. Any questions for the Keycloak crew? Looks like we do have one in chat. Can Keycloak be used for authentication to Kubernetes itself?
Yeah, it can, yeah.
Other comments from the AWS crew that says fantastic work. Kudos to you and team, of course. We do have 1 to 2 minutes left for questions. If anybody else has one, feel free to jump in.
What other programming languages are there mature libraries for?
So we have support for primarily Java-based ones and Node.js. But you can use any SAML libraries or any OpenID Connect libraries, and you can mix and match between the two as well. So you can have some clients using SAML and others using OpenID Connect. And we are soon introducing a Go-based proxy adapter, which you can then sit in front of any type of application to secure it.
Or so many people in the community are using this Go-based proxy in the sidecar as well.
All right. Looks like Bob at University of Michigan actually uses Keycloak and says this works great for Kubernetes Auth. And then we'll take one more. Is it like similar to OpenAM, which is used for access management?
So we have some overlap, and that it behaves slightly differently. But we have what we call the Authorization Services, which is based on the UMA protocols that allow you to set up fine-grained permissions for your resources and centrally managed access to everything.
All
right. Thank you again so much for coming in now. I
would just say for the OpenAM, so OpenAM is a beast. So both are authorization service, but OpenAM is a beast, and I think it's not open source anymore. So we try to be more focused on modern use cases and more lightweight.
Cool. And then if anybody else has questions for the Keycloak crew, go ahead and keep those in chat, and Keycloak, feel free to use chat for that. All right. Our next part of the session today is our release updates from our awesome shepherd, Tim Pepper. Tim, you want to take it away?
I've got kind of two main things that I want to talk about. The first is there's a proposal in flight, and it's linked in the minutes here. It's out on KDev, and so far it seems like generally the SIG leads are liking the proposal. But the proposal is to drop the status approved for milestone labeling as a requirement for merge during code freeze. So that's kind of redundant at the moment. But I think what I wanted to say here about that a little more so we've got code slush coming up next week and code freeze the week after that. And regardless of what we choose for mechanisms around enforcement, there needs to be culture where our leadership chooses to start ratcheting down what they let into the master branch in this time phase. So just want to kind of give the shout out that we're heading into that phase. People need to be having rigor. Obviously associated with this, we are needing things like documentation, test cases coming in as well. And then the other major aspect of this is the reason we ratchet these things down is to get stabilization, and have some slight worries right now. It's getting better as the week progresses, but our CI status is a bit unhealthy looking. Last week, we did get our 1.12 branch CI up and running, but even before that, our master branch health was looking a bit worrying. So there's a cluster of, or a number of clusters of issues that we're reaching out to a number of SIGs. I've got kind of the list of potential parties there that we're needing some help from. And I guess I just mentioned that cluster lifecycle is last on that list because even though a number of these are upgrade failures, they don't look like they're cluster lifecycle upgrade failures. So it's easy when you glance at test grid maybe to think, oh, this is an upgrade issue, cluster lifecycle will be on it, but it's actually often more than that. So would appreciate additional eyes on some of these things. And then I'm not sure if Maciek is on the line, but probably for the patch releases, the only thing to mention is that 1.10.7 just came out this week. And that would be the update.
All right. Any questions for Tim or release team or any of the patch release updates folks on that want to add anything else? All right. Thanks, Tim, as always. All right, next up we have Aaron, who is going to share some GitHub automation stuff with us. Aaron, you want to take it away?
Sure. Hi, everybody. Aaron Krickenberger here, your friendly GitHub label guy, steering committee guy, testing guy, Contribex guy, beard guy. Yes, the t-shirt says I have no idea what I'm doing, but thankfully I have graphs to sort of help you understand what I think is happening. So today I want to talk about our automation's GitHub API token usage. As some of you may know, the token you get for GitHub's API gives you 5,000 requests per hour. That is a limit that we've kind of come close to hitting a number of times. Initially, when we use nothing but munch GitHub, the thing that sweeps around and does things to things it finds, whatever, we're going to deal with this in the dark. We dealt with this initially by having munch GitHub keep an in-memory cache. This contributed to munch GitHub being a real pain operationally because it took forever to warm this cache up on restart. Once we got that in place, we then had to sort of tune the frequency with which munch GitHub went around and pulled things because we found it ran out of stuff per hour, or munch GitHub's client would have to kind of exponentially back off. Then we kind of separated munch GitHub into two instances, one just for sweeping through and doing submit queue related things, one for sweeping through and doing all the fun things with like labels and tests and stuff like that. We then gradually moved to Prow, which instead of sweeping through things, responds to things as needed, which definitely helped us keep our token usage down for a bit. But because Prow is so awesome and everybody wants to use so much of it, we started creeping back up to that wall. So we eventually decided, you know what, the idea of having a proxy for GitHub or a cache for GitHub was pretty cool. We just hate having it in memory. So thanks to Cole Wagner for working on this thing called GH proxy, which I'll link here just to follow. This is, I think, in theory, something anybody could use. And GH proxy is just a reverse cache, a reverse proxy in front of this cache, which is a little more GitHub specific. If you want to find out all of the fun lessons that Cole learned while implementing this, I suggest you read the code and the READMEs. But today, since this is graph of the week, now that I've told you the story, let's show you the hero graphs. So I'm going to show both two graphs. Let's see if I can get this to go side by side. So on the left side of the screen, you can see graphs for our GitHub cache. Wow, this is really maybe not going to be as cool and awesome. But I kind of want to point out that the graph here shows that we turned on the GitHub cache about midway through May. Certainly by June, we turned on the GitHub cache. And you can see fun stuff like how often we are hitting versus missing the cache, how many tokens we think we have saved cumulatively over time since we've started the cache up, how efficient we're being. This is good. Metrics are awesome. You can see your success. Now let's take a look at these fun graphs on the right side, which I will expand. So these are graphs that more or less pull munch GitHub and kind of pulled something from Prow as well. The graph I'm most interested in is up at the top. It shows our GitHub token usage. You can see over time that it was kind of up here and often poking up into the yellow thing, sometimes even maxing out in the red area, which is super bad. And then you can see around about the end of May, after we turned it on and kind of got used to what the cache is supposed to look like and hooked everything up, our GitHub token usage has gone down significantly. I know this looks noisy, but the yellow line here is kind of like the rolling average for Kate's merge robot, which is munch GitHub, which today really is just the submit queue for KK. And the green line represents the rolling average for Prow. So you can see that both lines kind of went down as soon as we turned on the cache. That's super cool. Another way you can see success here, back over here where like GitHub token usage got completely maxed out. Guess what? That's generally what happens when we come out of code freeze and there's this huge stampede of pull requests that need to be merged. So that's kind of what you're seeing with this spike here. That's why I'm showing all the graphs at the same time. And so as we were churning through all of that, our token usage was maxing out. With the cache in place, the next time we had a similar peak of pull requests come through, we churned through them, but we didn't blow through our token usage. And so as a result, we were able to churn through the backlog significantly faster. This is awesome. Hopefully this is the last time you're going to see graphs like these in any informative manner. We do still have a desire to move away from Munch GitHub and towards Prow's implementation of the submit queue. It's called Tide. I don't have anything to show you about that today, but rest assured, we're going to have similar metrics to make sure that Tide is doing things successfully. I've been turning on Tide for pretty much every single repository out there as a result of sweeping through all the automation. I gave you a heads up about this last week. So folks in Kubernetes Incubator and Kubernetes, look for me to start coming to you about all of that. I'm going to stop sharing. Any questions? Is there an umbrella issue or GH project covering the transition to Tide? So I do have an issue in test infra, which I will link both in chat and add to the meeting notes shortly. I think that is it. Thank you so much. I'm going to go find out how to turn the lights on.
Thank you. Please get the lights on. That would be awesome. Aaron, always entertaining as usual. Thank you, Sigbeard. All right. Oh, Josh, shouldn't there be a cap for Tide? Oh, Josh. All right, so next we actually do have a KEP, and again, for those joining late, KEP is a community enhancement proposal. You can find those in the K community repo for now, at least. And let's see, Tim, do you want to take it away for your KEP? And also for those following along, the KEP link is in the agenda today, if you would like to continue. Okay, go ahead, Tim.
Hi, can you hear me?
Yes.
Yeah, okay, great. Let me just go ahead and present.
I can present it for you, Tim, if you want.
Sure.
Sure.
Yeah,
Okay, hold on one second.
So I can start talking about it without, you don't need to read it. So this kept called runtime class, and it's for a new way of expressing the runtime that should be used to run containers in Kubernetes. This is motivated by some of the new runtimes that are being developed now, including Kata containers and gvisor. The kind of root motivation there is for better sandboxing of containers. We're also kind of thinking ahead into the future as well, that we may come along with serverless runtimes or Windows runtimes, and probably some stuff that we haven't thought of yet either. And so runtime class is sort of the generic way of identifying a runtime to run with. And you have this problem in Kubernetes that the runtime is totally managed by the kubelet, and there's no information surfaced to the control plane about the runtime. And once you run a heterogeneous cluster with different runtimes on different nodes, or even nodes with different runtimes on the same node, you run into a problem where things like scheduling decisions need to know what the overhead of a certain runtime is. You need to know which features are supported by different runtimes so that you can do that validation at the control plane level. And you don't have to wait for something to be scheduled to the node before you say, actually, I can't run this. So those are sort of the two primary goals of runtime class. The first is to support multiple runtimes, and then the second is to provide a mechanism for surfacing the information and the properties about those runtimes up to the control plane. So Paris, if you don't mind jumping down to the API section. So the runtime class object itself in this alpha proposal is extremely simple. It's basically one object that has a name and a single field called runtime handler. Runtime handler is just an arbitrary name that's been given to the runtime by the configuring user, so the administrator, whoever sets up the nodes. And that is that just maps to a specific configuration to run containers with. And then this is referred to from the pod spec, where we're going to have a runtime class name, which just refers to the runtime class object itself, and lets the user or whoever's deploying the pod select which runtime to actually use. And this layer of indirection will probably come in handy more in the future, but right now we wanted it to be able to decouple the configuration piece and the implementation at the node level from the name that the users actually have to refer to. And that will become especially important once we start adding more features into the runtime class spec itself, and may end up with different runtime class specs for the same runtime. Yeah, that's basically the proposal as it stands right now. Actually, if you want to just quickly scroll back up to the top, but non-goals. Thanks. So right now, runtime class is this extremely simple, just basically one string field. But we have a lot of ideas of where we want this to go in the future. And every time I present this, people always ask, could we add this feature and this feature? And the answer is, to some extent, yes, we want to add a lot more to this. And here's a lot of the ideas that we've thought about. But we're trying to keep it very simple and very scoped down for the initial implementation so that we can kind of iterate and put more thought into each one of these. A few to call out, I already mentioned pod overhead. Right now, resources in Kubernetes are only associated with containers themselves. And there's no resources that are associated with the pod itself. When you have sandbox runtimes like Kata containers, you're running a whole Linux kernel in the pod that's not associated with a specific container. And so you end up with a lot more overhead for the pod, and the scheduler needs to be able to account for that. Other ideas are around fitting of runtime properties. So rather than having to name a specific runtime class, wouldn't it be great if I could just say, this is a security sensitive workload, give me a sandbox runtime, or give me a Unix operating system. I don't care which one, I don't have specific requirements, or maybe I need GPU support. And if you can just express these properties and the scheduler can, or some component in the control plane can pick the right runtime based on availability. Another one worth calling out is surfacing optional features. So we already have a bunch of different features that are supported sort of optionally. One basic example is AppArmor and SE Linux are currently mutually exclusive in Linux. And so any given node is only going to support one of those, but we can express both of them in the pod spec. And we don't do a great job today of identifying optional features, identifying what features are supported, and how unsupported features are handled is also inconsistent. And so the idea here would be to add some sort of way of describing which optional features are supported in the runtime class, and then in the control plane have a consistent way of saying, you're trying to use an unsupported feature of this runtime class, so surface an error much earlier in the pipeline. So I think I'm already over time, so.
Yeah. We do not have enough time for questions, but if anybody does have questions for Tim, feel free to pop those in chat. And then Tim, if folks would like to comment on this further outside of this call, where should they go?
There's actually an open PR to mark this as implementable. So feel free to add comments on that. I can link it to the agenda. Also, feel free to reach out to me. And this is this KEP is being discussed in SIG-Node, so that's another forum for discussing it further.
And I'm so used to associating you with auth, so that's why I put the auth KEP in there. So sorry for the confusion, everyone. Clearly, we have multifaceted contributors who dabble in all areas. So sorry about that, Tim. All right. So did somebody say anything? All right. Next, we are going on to our SIG updates portions. And first up, we have Chris with Openstack.
Hi there. Is it easier for you to show the slides, or do you want to have me share them?
I think it might have just been the room that Tim's in that was having the issue, because we have a little Zoom hack going on in there right now. So we try to go ahead and share yours first, and then if it doesn't work, I can take the ones to choose.
Okay. Yep. How's that looking?
Yep. Perfect.
Okay.
Thanks, Chris.
Great. Well, this will be a short update, so hopefully we can catch up on a little bit of time for the rest of the meeting. My name is Chris Hodge, and I am one of the co-chairs for SIG Openstack, along with David Lyle and Robert Morse. Just a quick update of some of the work that we've done in the last cycle. So SIG Openstack has a bunch of different things that we've been working on. One of our primary things that we have is the cloud provider Openstack, which is both the cloud provider has both an entry instance and an external instance. Over the last few months, we've after doing a bunch of work on getting in a test grid and some other things, we've added a bit of conformance testing. We've done a bunch of it's mostly just been bug fixes and a little bit of performance enhancements. And so, things like adding the cluster name to the load balancer descriptions so that people can actually identify where their load balancers are. Lots of bugs, fixes and improvements, making sure that we are syncing bug fixes with the entry provider. Now, it's important to note that our entry provider is deprecated. Our original goal was to remove it in 1.12, but because of the number of existing users out there and the shorter timelines of Kubernetes releases, the 3-month releases, we will probably not start doing that work until 1.13. And so if you are someone who is depending upon the OpenStack provider in tree, you should start looking at how to use the external provider. In addition to the provider, we also have a number of different drivers that plug into the Kubernetes ecosystem. We've added a Manila storage provisioner. Manila is the OpenStack project that provides shared storage systems, and so this is very popular in within research institutions who like to have NFS volume mounts. We've also added config map support for our Keystone Authenticator, as well as added Keystone project synchronization with Kubernetes namespaces. And so if you have a Kubernetes namespace with a particular name and a Keystone project with a particular name, the Keystone Authenticator will regard those as, give you authorization to work across those. And so that's a pretty exciting feature that improves the integration between Keystone and Kubernetes. As well as block volume support for the Cinder volume plugin. One of the big things that we've also been working on is improving the documentation. We've put a lot of effort into documenting everything that we do, and also working with SIG Cloud Provider to to kind of make documentation consistent across all of the providers. And finally, we've begun the transition to become a SIG Cloud Provider working group. And so this may be the last update you receive from SIG OpenStack as we wind the group down and become a subgroup within the SIG Cloud Provider. And that moves us on to future work. So one of the things that we're really excited about is we have a review in for Magnum conformance testing for Kubernetes certification. This is something that is near and dear to my heart. I run this certification program for the Openstack Foundation, and so it's exciting that one of our projects gets to participate in the Kubernetes equivalent of that. So we should be looking for, hopefully, Magnum to be a Kubernetes certified installer for the release that's coming up. We're still working on our 2 auto-scaling drivers. One is based on OpenStack Heat, and one is based on OpenStack Semlin. Storage driver consolidation is also in the works. As well as a new project for Barbican, as building a Barbican driver for key management. Again, as I mentioned before, we have a plan for the start removing entry code for the 1.13 release, and we're going to continue to work with SIG Cloud Provider with short-term goals for building generic docs for the entry and external providers. And also build provider-specific docs that's going to be used as a model for the other cloud providers to kind of build their docs off of. And so this is, it's kind of exciting to see all the collaborations that we have, with SIG Cloud Provider, but also SIG Docs, and they've been fantastic to work with, as well as Csi Cluster API, which we've also been active participants in. So to wrap things up, if you are interested in getting involved with any of the work that we're doing, our group meets at a number of different events. September 10th to 4th, we're going to be at the OpenStack PTG in Denver. Registration is still open for that, as well as for the OpenStack Summit in Berlin in November 13th through the 15th, as well as KubeCon, Cloud Native Con in Seattle. So with that, I'll wrap it up and take any questions that people might have.
We can take one question live. All right.
Oh yeah, we had a question. Where do we host the driver code? That is in the upstream Kubernetes cloud provider OpenStack repository.
Cool. All right. Thank you so much, Chris. I really appreciate it.
Yeah, thank you.
All right, and then next we have Saad with storage. And then for those following along, the slide links are in the agenda too for all 3 updates today.
All right, thanks, Paris. So my name is Saad. I'm SIG lead of SIG Storage. Today I'm going to give you a quick update of what we've been working on for the 1.12 release, and then answer any questions you might have at the end. So the big items that we have for 1.12 are topology-aware volume scheduling. This has been a multi-quarter effort. The basic idea here is that different types of volumes may not be equally available to all the nodes within a cluster. Previously, Kubernetes has a hard-coded logic to handle this for 2 volume plugins, the GCE persistent disk and the Amazon EBS volumes, to understand the concept of zones somewhat. It was a pretty poor solution, and it didn't scale to arbitrary different volume plugins. In the last quarter, we actually implemented topology support in both Kubernetes and on the CSI side. And in this quarter, we're implementing topology support in the entry volume plugins, using the functionality that was exposed last quarter. This is for the GCE PD ones, the AWS ones, as well as the Azure one. And then we're also adding support to the bridging logic between Kubernetes and CSI to enable this end-to-end for CSI volume plugins. Some of the use cases that this is going to support, some of the new use cases are the ability to have volumes provisioned in a smarter way where the scheduler can help influence where a volume is provisioned. Today, once you create a PBC, it kind of gets randomly assigned to a zone, for example. In the future, we can make smarter decisions using the scheduler. So this is a lot of multi-quarter work that's all coming together. Next up is snapshot and restore functionality. So this has been a long and winding road for SIG Storage to figure out how and if we should have the snapshot and restore functionality as part of the Kubernetes storage API. I think ultimately within SIG Storage, what we realized is that it's a common enough operation that it is good to abstract it within the Kubernetes API. But we were at a weird place within the wider Kubernetes community where the recommendation from SIG architecture is that there shouldn't really be any more core API objects that are going into the API. Everything should be added on as a CRD. There is a number of reasons behind this we can elaborate on, but what this meant is this is one of the first Kubernetes storage features that couldn't be part of the core, and we had to figure out how to make that work. Luckily, it's worked out very nicely. We have an external snapshot controller along with CRDs, and that's going to be released as alpha at the end of this quarter. And then we're going to make some minimal set of changes to the Kubernetes core to enable this functionality. That is adding in a data source to a PVC object. This will allow, when you provision a new PVC, to be able to say, I want it to be pre-populated with a specific snapshot. In the future, we plan to expand that to be a more generic hook that would allow you to pre-populate with any type of data. It could be another PV that we clone. It could be, a Docker image. It could be a GitHub repo. We want to support arbitrary external populators paired with external provisioners, kind of working dynamically together. So that's the long-term vision for this. I'm really excited about that. Next up, we're preparing CSI for GA in Q4. CSI is our out-of-tree volume extension mechanism. And it was introduced late last year as alpha. Since Q1, it's been in beta. We've been working on improving a number of pieces of CSI. The things that we're focusing on this quarter for CSI are supporting ephemeral volumes. So I think remote persistent volumes work fairly well with CSI at the moment, but local ephemeral volumes, so think things like a secret volume or a config map volume, or maybe like a Kerberos token injection volume, don't really work very well with Kubernetes, with the CSI that we have at the moment, or at least the Kubernetes CSI implementation that we have at the moment. So we have a number of projects to make that easier this quarter, and we also want to nail down some of the basic functionality for how you connect to a CSI driver. So we had the kubelet device registration mechanism introduced as alpha last quarter. We want to get that pushed to beta because CSI relies on it, and we want to make sure that that's GA'd before, along with CSI. And then we're also adding in a couple of new API objects that will help with some of the functionality mentioned above. CSI Cluster Registry is an idea of introducing an object to represent a CSI driver within the Kubernetes API. One of the benefits of this will be ease of discoverability of what drivers are actually installed on your cluster. So you can do something like kubectl get CSI drivers and get a list of the drivers that are installed. But it also serves as a mechanism by which an arbitrary CSI driver can configure how Kubernetes interacts with it. So I talked about these ephemeral volumes above. Today, Kubernetes does an attach operation on all volume plugins, regardless of the volume plugin. But you can imagine that an ephemeral volume could have a configuration that says, I don't need to do an attach. Please skip that operation for me when it registers itself with Kubernetes. So that's in the works. And then node status API object is we want node-specific information for CSI drivers, things like what the driver thinks the node's name is, what the topology key prefixes are, things like that, which are very node-specific. We want to be able to capture that information, but we don't want to continue to extend the node object, which is getting very, very large. So we're thinking about introducing a secondary object to capture that information. All those discussions are ongoing in various KEPs. Please reach out to me if you're interested in those. And we're also trying to come up with reusable libraries for some subset of CSI drivers. So for example, iSCSI is the basis for a lot of CSI drivers, and the mounting logic can get fairly complicated. So what we're trying to do is abstract away that mounting logic into a library that other CSI drivers can then import and built on top of. And they can implement things like the provisioners, which tend to be very custom, but reuse that core driver mounting library. And we hope to do that for other common protocols as well. We also have a big effort underway this quarter to add conformance testing for storage to the Kubernetes conformance suite. Michelle has been leading that effort, and if you're interested, I will put you in touch with her. And then finally, block volume support. You just heard that SIG Openstack was implementing block volume support for their volume plugin. We're going to move that functionality from alpha to beta. It's been in alpha for a few quarters. We wanted to make sure that we got it right before we moved it to beta, and that is being moved this quarter. As for what's next, so before 1.12 is cut, we need to get the features out and then ensure tests are all there for the new features, fix any bugs and add documentation. And then post 1.12, our biggest push for Q4 is going to be to drive CSI to GA or stable. Please get involved. We have bi-weekly meetings. All the information is there. We have a Slack channel where folks are fairly responsive, and this is out of date, but we will be at KubeCon Seattle, so please keep an eye out for that. Any questions?
Can you read, please? That's good. We do not have time for questions, though, but if you do have questions for Saad and or storage team, ask in the chat or get involved on that slide. Thank you so much, Saad, for coming today.
Thank you.
All right, next up, we have Matt Farina with SIGAP. And then, Saad, you want to stop sharing your screen? And, yeah, we are good. All right.
All right, can you see?
Yes, I can.
All right, fantastic. So what is SIGApps? For those of you who might be unfamiliar with SIGApps, we cover deploying, developing, and operating applications in Kubernetes. We're really looking at it from the application developer and application operator point of view. We kind of have a few areas we're working on right now. One of them is an application CRD and controller. We have the Workload API under SIGApps. There's an application called Compose that came out of the old incubator process and the example space. We also used to have Helm, but now it's a part of the full CNCF project. I'll touch a little bit on that, just what touched Kubernetes since our last update. But those are kind of the areas we're handling these days. The SIGApps charter is one of the things that we're actually working on right now. It's coming along. We'll have it ready to review again in the next couple of weeks, given some of the changes that have been happening. But this is one of the things that we've been poking at again to bring it back up to speed as reviews are happening. One of the things that got merged is, SIGApps is concerned with tools being developed by different companies, different things that are going to manage applications in Kubernetes. And an application, in our perspective, is a collection of Kubernetes assets meant to design and to run an application. For example, if you're going to do a site like the ever example WordPress, you've got probably a deployment, you're running a database that's probably running as a stateful set, you've got a service exposed, maybe load balancers, you've got a bunch of stuff that's going on that encapsulate your application. You want to have a point of view. Now, if you want to have many different things that can deploy it, maybe you deploy some applications with kube control, maybe you deploy some of them with something else, you want to be able to sort and filter and do stuff with them. And so one of the things that we worked on, and actually it happened under the AppDev working group, but the documentation is owned by SIGApps, is a set of recommended labels to use to specify, here's the details, here's your application, here's what manages it. And those were merged into the documentation. In fact, that's also been merged into Helm's documentation and upcoming releases of Helm to use this as well. But tools are starting to adopt a common set of labels so we have interoperability with each other. Another thing that we're working on is the application CRD and controller. This is an application, an actual custom resource that can describe an application. The code you can see is in the Kubernetes SIGs repo, but it provides a cross-tool way to describe an application as well. It's another one of those things that complements the labels and lets you describe, here's an application, here's details about, here's where you can get the icon for it if you're going to display it in the user interface. Here's where you can find more information on the maintainers of the application if they need to be contacted. Details like that that are useful both in a listing and at runtime can be grouped in this. And again, the goal of this is to provide cross-tooling interoperability. The work currently, we're working on a V1 beta 1 of it to just provide this, and it's slowly moving along. The next thing we have is the Workloads API, and there's 3 things, and we recently discussed these. We're looking at things like lifecycle hooks and how are we going to handle that, because that's something that was, if you look at the deployments and what originally came out of Red Hat's OpenShift that came into Kubernetes, they had lifecycle hooks. And it's something that we do find useful today. For example, Helm has its own version of lifecycle hooks baked into it. And so we're looking at how do we do more with that. We're looking at pod disruption budgets and deployments because there's actually some issues in there. And then jobs with deterministic pod names. These are a few of the things that we're looking at trying to come up with a strategy to tackle here. We talked about these just in the last meetings. But the Workloads API is getting dedicated time these days. We're trying to schedule, now it's a new thing, schedule time every other week where if there's something to talk about with the Workloads API, we're doing that. And then on the alternating weeks from that, we're actually talking developer tooling and things that go along with that. So our demos will reflect these, stuff like that, because we have demos every week. But this is what we're looking at with the Workloads API right now. There's Compose. We technically own Compose. Compose, for those of you who don't know, converts Docker Compose files to Kubernetes objects. From the application survey we did not long ago, earlier this year, you'll see it has some minor usage. It's not in heavy usage, especially with some of the other things that Docker has been doing lately. And SIGApps technically owns this, but it's mostly on autopilot, and we don't do much with it. It's rarely a topic of conversation. I had to go look it up. It is still actively developed, and it has had releases, in the last few months that continue just to have minor bug fixes and changes to it. So it's actively being worked on. Oh, I got a typo. It's version 1.16, not 0.16, was released. And so it's actively being developed, but there isn't a whole lot of conversation on it these days. Helm moved to the CNCF just before our last update in June, but even though it moved to the CNCF, everything still lived under the Kubernetes org as of the last update. Since then, we've actually moved all the Helm stuff over to the Helm org on GitHub, so Kubernetes folks don't have to worry about that anymore. But Charts is still using the Prow and Tide automation because it turned out that's quite useful when we've got to have many owners of many different charts. And so we are continuing to use that automation like so many projects are starting to do. But that's what's going on with Helm. And that's my quick update. Are there any questions? Do we have time for questions?
Not really, but if anybody has any questions, pop them in the chat. We might be able to take one. Last call for Matt. All right. Awesome. I think you do have one in chat, Matt.
Yeah, I'm happy to talk about that at another point because Helm's not really under Kubernetes anymore, so we can jump that out. If you want to catch me in a side channel, I am very happy to talk about that. But since we don't have much time and this is not a simple topic, I don't know that I can really squeeze it in here.
Okay, fair. All right. Now we are going into the announcement section, and we have a lot to talk about, and we only have 5-ish minutes left. So I'm going to run through this as fast as possible. Quickly, we always do shout outs. Our shout outs are pulled from the shout out Slack channel. So please feel free to give folks a quick thank you for work that you've seen that is above and beyond, or just naturally awesome. First one's from Nakia. Shout out to George for his video on how to use discuss.kubernetes.io. That's a new communication platform that we stood up that's attached to the Kubernetes website. Feel free to watch that video and tell you how to do things like use it for your email client and things along those lines. So thanks to George for that. I'm shouting out DIMS for improving the contributor experience. The script that DIMS created with the PR link in the agenda is going to reduce some of the manual assignment mistakes to pull requests. Awesome stuff. Christoph also wanted to shout out Neolit123 and Nikita, who also been doing the same work, improving the contributor experience as of late. And then last, Nikita also wanted to shout out Christoph B. Blecker for everything that he does for the community, especially for keeping the project sane with buyers. So thanks to everybody that got a shout out this week. And then Aaron, you're next with both the TypeScript and automate all the things, and you have like maybe 1.5 minutes.
I will go super fast. So first off, I have retired the TypeScript repo. It was deprecated. This is something I'm supposed to do as part of repo removal process. I did it, it's done, yay. Next up, progress on automating all the things. I talked about this last week. All the labels are in all the places. All the repos are in SIG's YAML. That's how DIMS got to do his awesome thing. There is one repo left that doesn't have an owner's file at the root. And then the only orgs that don't use Tide for merge automation are Kubernetes Incubator and Kubernetes Incubator and Kubernetes. I will be poking individuals to get that done. And then finally, whether or not Kubernetes should move off of the submit queue to Tide. I personally believe that is unwise since we're so close to code slush and code freeze, but I will be poking the relevant people offline about that. And I'm out.
Awesome. Perfect. All right. And then next up is about the Contributor Summit that's happening in Seattle. For those who are interested in attending that, we'll have both a new contributor workshop as well as content for current contributors. That is a part of the KubeCon registration process. In order to attend that, you have to add it as a co-located event in your registration. That's December 9th and December 10th. So please sign up for that. Also, the steering committee election announcement went out on the 21st or the 22nd, depending on where you are in the world, and that went out on the Kubernetes development mailing list. Please check out all of those details. Everything you need for voting, nominating, etc., is in that email with a lot of detail. The next deadline that everybody needs to be aware of is September 14th. This is for nominations are due, as well as exception forms for eligible voters. So please definitely look at the schedule, look at the details. We'd love to have you in the nomination process and also your vote count. All right. George, do you want to take it away about the contributor role board? I can also read too if you're not. I think you might be having internet.
Hey, we're running out of time, so we'll skip it. Show it next week, but click through if you're interested in getting started early. Thanks.
Okay. All right, and then the last one is about the Contributor Summit in Shanghai. They're not doing a large current Contributor Summit. However, they are doing a social at the end of the new track that they're presenting at Shanghai. The venue and the schedule details to be announced. However, same as Seattle, in order to go to that event, it is a co-located event on the registration for Shanghai. So just please please look out for that detail. All right, and that wraps our show for today. Same time, same place next week, and happy Thursday. All right.
Thanks,
Bye,
Paris. See y'all.